the applications of quadratic features, roots, and then using their roots to find some values. Suppose a quadratic equation is given as 3x squared minus 4 minus 1 all equal to 0, and its roots are alpha and beta. Compute the values of the following. These ones. We need to find their values. That is it. Okay, we are going to begin right away by, first of all, writing out this quadratic equation. That's the first thing. We write out the quadratic equation as given. Okay? And that is 3x squared minus 4x minus 1 all equal to 0. At the same time, we need to consider the coefficients of x squared, x respectively as a and b. So a has 3, that's the coefficient of x squared, and then b is equal to minus 4, the coefficients of x, and then c is just minus 1, the constant term. That's all. The next thing we begin to apply respectively according to the roots given. Okay, so let's find question I. We have alpha plus beta. Okay, you should know that alpha plus beta, according to what we learned in our last class, is given as minus b all over a, right? So if we have this, what do? We substitute. We already know that b is minus 4. Already the formula has minus. So we begin minus. That's the first one. Into parentheses or brackets, so to say, minus 4, which represent b, the value of b. Minus 4 all over a. A is 3, so we have this. Okay? For the simplification, we have that alpha plus beta is equal to, this times this is 4, and then all over 3, solved. So we have solved this. We have found the roots, or the value of alpha plus beta to be 4 over 3. That's it. Then the second question, that is I. Let's see how it goes. We bring it out. 1 all over alpha plus 1 all over beta, okay? All equal to, the next thing we need to do here is to find the LCM. Let's just find the LCM. Once we find the LCM, the remaining aspect of it is very simple. We find the LCM as alpha and beta, product of alpha and beta, okay? Alpha divide this, of course, it will cancel this. What is left is beta. Beta times this is going to be this beta, and the same thing happens alpha. This divide, cancel this, and we're left with alpha, multiply this, we have this. And remember, according to symmetric features of quadratic equations or quadratic roots, this is equivalent to alpha plus beta all over alpha beta. So it doesn't change anything. Nothing has changed. So remember, we've done that before. So let's just use that simple knowledge and then finish the remaining aspects. So we have alpha plus beta all over alpha beta is equal to, alpha plus beta is given as minus b all over a all over c over what? A. So we can simplify this further by saying minus b over a times a all over c. Okay? So this a will take care of this, and we're left with minus b over c, and this is just minus b over c. I'm laughing because my truck is just breaking intermittently. Alright, so let's see. We have this. We can still check what we've just done to see some clarity here. if we finish this the way it should be, look at it. It should be minus b, right, over a times a over c. And this, we take care of this. I'm repeating it for clarity's sake, clarity's sake. So we have, what is remaining here is simply minus and c minus b all over c. That's it. So if we take it from here, we now know that alpha plus beta all over alpha beta is equal to minus b all over c. We give us for minus b, we have minus 4. And then for c, we have minus 1. Okay? And this boils down to this positive minus 4. Okay? Therefore, alpha, where's the question? 1 over alpha plus 1 over beta is equal to minus 4. Solved. Take notes. We've solved that. So we move on to question number 3. Question number 3. Let's see how it goes. Question II. That's question number 3. II. Look at it here. So we have alpha over beta plus beta over alpha plus beta over alpha. Alright? So what do? We do the same thing. Find the LCM again. Should be beta alpha. Okay? And that goes beta divide this, it will cancel beta, and we are left with just alpha. Alpha multiply this gives alpha squared plus sign. You go again, alpha divide this is going to cancel alpha, and we are left with beta. Beta times beta is going to give us beta squared. So if we continue in that way, if we continue like that, we can as well say that this is the same thing or equivalent to alpha plus beta all squared all over alpha beta. Remember symmetric properties as we learned before, or symmetric features as we discussed earlier. Alright? Okay, so with that, we now have alpha plus beta all over alpha beta is equal to, what do we have as alpha? This is minus b all over a, okay? Then c all over a, all this. But remember this is squared. So whatever we have here should also squared to avoid confusion. Okay? So let's go. For this, we have minus 4 for b, alright? All over a is 3. A is 3. So we have 3, okay? And then for c, we have minus 1, and then for a again we have 3. So watch this. Remember, we need to square all this. We need to square all that. Take notes, watch it closely. Then, the next thing. Minus, minus. Cancel that positive. 4 squared is 16. Alright? 3 squared is 9. Alright? We don't have any square here. We have minus 1 all over 3. We return that way. Okay? So we continue. From there, we continue. And we can now see that this is very, very important at this point in time. We can now see that alpha plus beta, and then beta over alpha can give us 16 all over 9 times minus 3 all over 1. That makes sense, I think. Yes, it makes sense. It makes sense. Let's see how it goes. Alright, we have minus there. So what do? We're talking about this. So what do? At this point, okay, so we cannot say that we have this is going to be minus 16 times 3. 6 times 3 is 18. We write 8 carry 1, and then 1 times 3 is 3 plus 1, that's 48, minus 48 over 9. What goes? Can we have this? Can we have this? Yes, so let's see. If we can have this, what goes? Or we can leave it at point. We can say that this is equal to this. And that solves it. Minus 48 over 9. So let's see what number goes. 5 goes here. 5 goes, cannot. 5 cannot. Okay, 3 goes. That's 16. 3 goes. That's 9. Okay. If we go, it becomes minus 16 and then 3. Yes, because 3 can divide 9. 3 can divide this. Can we go again? No, we can stop at that point. So we have minus 16 over 3 as that. That is it. I hope I have not forgotten anything. I hope this is plus 16 squared. And squared 9. So we have that. All true. Okay. And what again? There's no factor there. So it's correct. So look at that. So we have solved from 1 to 3. You can as well prove that you have learned how to solve these things by solving question number IV, V, VI, and the rest. Convince yourself that you have learned how to solve this. You know what? I am signing out to prepare for the next lesson.